This is just simply a question to understand, or to demonstrate understanding of these inequality symbols. Is 4 a solution to each inequality below? The way you answer this question, it's a yes or no question, is substitute the variable x for 4. Is 4 less than 4.1? Yes. Is 4 greater than 4? No, 4 is equal to 4, so this is no. If it said greater than or equal to 4, then the answer would be yes. Is 4 greater than or equal to 4.1? Is 4 greater than 4.1? No. Is 4 equal to 4.1? No. If it's not true for either or, then the answer is no. Is 4 greater than or equal to 3.999? Is 4 greater than 3.999? Barely. Is 4 equal to 3.999? No. So is it greater than or equal to 3.999? Yes, it's greater than 3.999. This is very different than if I put the dot, dot, dot. If it was 3.9 repeating, that would equal 4 exactly. We talked about that earlier this year. Write, then graph an inequality to represent this situation. Grant decides not to spend more than $4 at the store. So if he decides not to spend more than $4, could he spend exactly $4? The answer is yes, because if you spend $4, you're not spending more than $4. So let's let X be the amount of money Grant spends. He could spend $4 or any amount less than $4. So he could spend less than or equal to 4. That's the inequality. When it says write an inequality, this is an inequality. The graph is going to be obviously graphed on the number line. So X could be any value less than 4, or it could be equal to 4. Since it could be exactly 4, we put a solid dot at 4. And since it could be any value less than 4, we put an arrow to the left. Now, when we start introducing word problems, clever and correct students always ask, you can't spend negative money at the store. That's absolutely true. That would be like walking in the store and just for walking in they give you money. That sounds like a good, that's a store I'd like to visit, but that's not a real situation. And so it's correct to say that this would end at 0, but that's a compound inequality and a little bit more advanced than what we want to do right now. So just if it's less than or equal to, let's just imagine that it goes all the way to the left, even though we know realistically it would have to end at the 0. I want to talk about, we said this is the graph. I think it's obvious what the graph is. It's sometimes confusing to students what I mean by an inequality. This is the inequality. This is the statement saying what X could possibly be. This problem doesn't ask you to write the solution set using interval notation, but I'm going to show you the interval just so you see all three of these things, so you can distinguish between the inequality, the graph, and the interval, or the solution set. The interval or the solution set are all the possible values of X. Since that arrow is going to the left, the least possible value would be negative infinity. The greatest possible value would be 4. And since it could be exactly 4, we would use brackets on the 4. Infinity and negative infinity always get parentheses. So if you're asked for interval notation, this is what we're referring to. This notation to show all of the possible values of X. It's the range of values that X could be from the least possible value to the greatest possible value.